All right, so we're going to look at a projectile motion problem where our object goes up in the air and then back down. So we had this in our notes from projectile motion part 1. We've got a tennis ball thrown straight up with an initial speed of 22.5 meters per second, and then it comes back down and is caught at the same height from which it's thrown. So we want to know two things. How high does the ball rise above the height that it was released from? And then how long does the ball remain in the air total? So let's look at our problem here. We want to sketch it out to kind of get a feel for what's happening. Here's our tennis ball, and it is going to be thrown up into the air, and then it will reach the top of its path where it'll slow down and stop, and then it'll come back down on the other side. Okay. Now at the bottom, we know that it's got an initial velocity of 22.5 meters per second. And then we know at the top, when it reaches the top of that path, before it starts coming down on the other side, it's got a final velocity of 0, just for that instant before it starts coming back down. Okay? Also, we know that this is an object that's in flight. It's under the influence of gravity. So what else do we know? We know that it is accelerating at 9.8 meters per second squared. And since we're going up, it's going to slow the tennis ball down. So I'm going to make this a negative because it's going to slow down on the way up. Okay? We want to know two things. We want to know the height that it reaches, and we want to know the time that it reaches. Now we can't solve for two different variables, so we're going to need to do this in little pieces. First, let's look at the distance. How high does it reach before it starts coming back down? Well, let's look at what we know. We've got VI, VF, A, we want D, which formula involves all of these but does not yet involve time. That one that we love, that ain't nobody got time for that, right? VF squared equals VI squared plus 2 times acceleration times our change in distance, okay? So at the very tippy top, our final velocity is 0 before it starts coming back down. At the bottom, we launch it with 22.5, and that's got to be squared, plus 2. Our acceleration is negative 9.8, and then our final distance is what we're looking for. We can set that initial distance as the person's hand. That's where the ball starts. So I'm going to make that one a 0, and it'll go away. Okay, 0 squared is still just 0. 22.5 squared is, oh no, it's all right. There we go. It's 506.25. It was off the page. Sorry about that. 22.5 squared is 506.25 plus 2 times negative 9.8 gives me negative 19.6, and then df. Okay? Don't be tempted to take the 506 and subtract the 19.6. Right now that 19.6 is being multiplied by df, so we can't split those up quite yet. They need to hang together for a little while. What we can do is pull the 506 over to the other side so that we can get that df all by itself. We can start that process. So I have negative 5.6.25 equals negative 19.6 df. Now I can split up the 19.6 and the df. So how do I do that? How do I split them up if they're currently being multiplied? Opposite of multiply is divide. So I need to divide by negative 19.6, and that will give me a positive 25.83. So our final position up here, how high we reached, was 25.83 meters. Okay, so we must have shot this out of a cannon. That's way too fast. We can't throw that with our hands. All right, the second part is we need to know how long it stays in the air. So this time we need time. Let's go back to what we know for sure. We know for sure the initial and final velocities, and we know for sure the acceleration. We Could use distance, but if we're afraid that we messed up on the math somewhere, let's not. Let's just use VF, VI, A, and T. Now, the best formula in this case would be VF equals VI plus AT. Our VF we know is 0. Our VI is 22.5. A is negative 9.8. And T is what we're looking for. Now again, just like we did over here, you cannot take that 22.5 and subtract 9.8 because the 9.8 is combined with that T right now. We're going to have to do something else. So just like we did with the 506, let's pull the 22.5 over. And then we can separate the 9.8 from the T. So now we can divide by 9.8. And we'll get T equals a positive 22.5 divided by 9.8, 2.295, which will round up to 2.30. Okay, so that is the time that it takes to get from where it is released to the top of its path. Okay, but remember, what goes up must come down. There's a second half to this right now. So if it takes 2.3 to go up and stop, then it's also going to take 2.3 to go down. So our total time of flight from when we release it to when it hits the ground again is 4.6 seconds. All right. So there's how you work a simple projectile problem where you go up and then back down.